we have a population function given as 250t over t plus 3, and the question asks us to find the instantaneous growth rate. So is the growth rate and the instantaneous growth rate, that is the derivative, pretty much. So to find the derivative of this, it is a quotient, obviously. So we're going to use the quotient rule. Let u equal to 250t. So u prime is equal to 250. V is t plus 3. V prime, derivative of that is 1. And then derivative of a quotient, u prime v minus uv prime over v squared. Right. So now we have derivative of this quotient. So pretty much we're going to have u prime v minus uv prime over v squared. So u prime v u prime and v is t plus 3 minus u v prime v prime is 1 of that over v squared t plus 3 squared. Multiplying out 250t plus 750 minus 257t over t plus 3 squared. Right. 250t minus 250t. So we just have 750 over t plus 3 cubed. T plus 3 squared, sorry. And then next, that's what is the growth rate when t is equal to 6. So pretty much we're going to put 6 in here for t. So p prime when t equal to 6, we have 750 over 6 is t plus 3 squared. So we have 750 over 81. Both of them divisible by 3, so divide by 3 on the top, 350, and then 27 at the bottom. Right, next. At what time the instantaneous growth rate is the greatest? So the instantaneous growth rate is the derivative 700 over t plus 3 squared. Notice that the derivative 750 over t plus 3 squared, t plus 3 squared, that is going to be greater than or equal to 0. Actually, it can only be greater than 0 because t at the lowest values of t is 0. So the population function, it should be noted that t is the time, or t is going to be greater than equal to 0. That's what we have here actually. So here we have positive. So as we say, t is greater than equal to 0, so t getting bigger and bigger, and eventually t plus 3 squared is getting bigger and bigger. So the smallest possible t plus 3 squared is where t equal to 0. Now if the denominator is the smallest, the quotient will be the greatest. So again, we want this to be the greatest, meaning the denominator have to be the smallest, and that's when t equal to 0. So I will write that is equivalent to is the greatest when t plus 3 is the smallest. And it has the smallest values when t equal to 0, because it just get bigger and bigger, than t plus 3 squared just get bigger and bigger, i.e. When t equal to 0. Right. And then next, evaluate the derivative limit of derivative of p to the t. So we're going to take derivative of this. Right. So this is a function, and we'll take derivative of this. Actually, that is the derivative. We just take the limit as t goes to infinity of the derivative. Right. As t goes to infinity, we just have 750 over something that goes to infinity, and a finite number divided by something goes to infinity, so that is going to be equal to 0. So that's what the limit is, equal to 0. Right. Next, we're just going to graph the function, and then we're going to graph the derivative. So just the calculator and just put it here. Right. So we're going to graph the function is 250t. I use x instead, divided by x plus 3. Right. Of course, we couldn't see much. We're going to change the windows later. Right. Let's put t is also greater than or equal to 0. So let's say t go from 0 to very big number. Let's say 20. Then we get, so the increment is 2. The y values also, let's just negative 10 to say 500, and then 100 for each, and then we'll see the graph. So the graph looks like this. Of course, if we see this is the function when t go to 0, when t goes to infinity, we have the horizontal asymptote of 250, where t and t cancel out. So we have the horizontal asymptote of 250. So let me draw that as well. You see the graph approaching to the horizontal asymptote. Right. We're not going to draw the horizontal asymptote. We're just going to draw the derivative. Derivative is 750 divided by x plus 3 squared. Yeah, so that should be fine, because we're going to do the square first and then divide by it. So if we're not sure, and the calculator allows us, so if you hit alpha and y equal to, if the bottom menu pop up like this, we can have the fraction of 750 over x plus 3 square. Right. And then we graph. If we hit graph, we won't be able to see much, because both graph will look the same. So what we want is I will graph the derivative in both. Right. So let's see the graph. So that is the population. The population we're approaching to 50, and then we have the derivative. Right. And the derivative is not going to go below the x-axis, but because we are using the bone line, so that's why it looks like this, but it does not go below the x-axis. Derivative cannot be negative. Right. In fact, what we see here is at t go to infinity, the derivative goes to 0. So we say based on the graph, we say the function will approach to a constant values, and then we say the derivative approaching to 0. Right. We put the calculator away for a moment. We do have the assess what happened when derivative go to infinity, when t go to infinity. So as t goes to infinity, the population, the derivative go to 0. Because of that, the function approaching to a constant. Because derivative equal to 0, the function must be a constant. So population approaches a constant, because derivative is approaching to 0, and derivative is 0, the function is a constant. So that's what we have.